Graphing lines method number 2, the slope-intercept method, and we have seen this already. Yes. Okay, so if you can write the equation in y equals mx plus b form, well then you know the slope because that's m, and you know the y-intercept because that's b, and so you can start by plotting the y-intercept and using your slope to find other points. So what does that look like? Ooh, this is in y equals mx plus b form. So I already know my y-intercept is at 0, oh, that's not negative 3. I already know that my y-intercept is at 0, 3. And I know that my slope is 2, which I can write as a fraction as 2 over 1. And if I know that my slope is 2, and I can write it as 2 over 1, well, the 2 is my rise over run, so I can then start from my point 0, 3, go up 2 over 1, find another point. I can do it again. Go up 2 over 1, up 2 over 1. I can go down 2, back 1. That would work as well, right? Can you see that down 2, back 1 is the same as up 2 over 1? Gives you a bunch of points. You can join the points, put arrowheads on the end of the line, and you've graphed it. Technically, would I have needed to have done 5 points? No. In fact, one other point would have sufficed to be able to draw a straight line. Uh-oh, is it more difficult because it has negatives? No. Y-intercept is at -1, so I can label that point 0, -1. Ooh, I actually would have lost marks on the last one just thinking about it. I've only labeled 1 point. So I made, by labeling that point, I made a scale along my y-axis. But nowhere do I indicate my scale along my x-axis. So I would need to label one other point, 1, 5. Then I would know my scale on my x-axis as well. So if you label 2 points, you're going to be fine. 0, -1. My slope is -3, which I can write as -3 over 1. Rise over run, that means I'm going to go down 3 over 1, down 3 over 1. If I label one of these points, 1, -4, I'm going to be able to graph my line, and that's fine. So with your slope, you can either think of the values as positive and negative and use that to help you figure out, oh, this case I went down 3 and then 1 to the right, and that ended up with my point. Or you can remember that a negative slope goes down from left to right. A positive slope goes up from left to right. With a fraction, does that make it harder? No, it actually doesn't. Because we still start off with our y-intercept, in this case, at 0, -3. And now our slope is 2/3. We don't have to change it into a fraction because it already is a fraction. Our rise is 2, our run is 3. So we can go up 2 over 3. That would get us to 3, -1. Up 2 over 3. If you wanted to label another point, 6, 1. Draw a straight line through those points. Put arrowheads on the end. And we're fine. So now we have to up the difficulty a bit. Ooh. X plus y equals 2. What's the problem with this one? It's not in an mx plus b form. What would you have to do to get it in mx plus b form? Get y alone. How are we going to get y alone? Right now, the y is having coffee with this x. So what do we have to do? Break them up. Subtract x on both sides. If I do that, I get y by itself. Negative x plus 2. You've never heard of variables having coffee together? No? Okay, well, it just happened. And now it's in y equals mx plus b form, so we know that the y-intercept is plus 2. So we can put that point on our graph and label it. Our slope, -1. Good. I was just going to do this, and then I was going to be confused. No, it is a -1, even though the 1 isn't written. And I can change that -1 to a fraction, -1 over 1. And so I'm going to go rise of -1, down 1 over 1, 1 comma 1, down 1 over 1, 2 comma 0. Fancy, right through that point. So the next one's the hardest, and I'm going to leave it to you to do on your own. Try it first on your own. Because it's not in y equals mx plus b form, and there's a number in front of y. Oh my goodness. Let's see how you do. To change this to y equals mx plus b form. It's trickier because we have a number in front of the y. So again, we're going to subtract x on both sides. I'm going to write that minus x first. And at this point, to get y by itself, you need to divide both sides by 3. When dividing both sides by 3, you can either write, right, I can show my work like this. And what that means is everything on the right-hand side is being divided by 3. The negative x is being divided by 3, and the 9 is being divided by 3. Now, 9 over 3 you can simplify quite easily. That's just going to be plus 3 at the end. Negative x over 3 is the same as negative 1/3 times x. Dividing by 3 is the same as multiplying by 1/3. The reason that's nice to do is because now we can say that our y-intercept is 3, 0, 3, and our slope is negative 1/3. Now, when you write negative 1/3, you can put that negative up with the 1 if you want, or you could put that negative with the 3. It doesn't matter. If I put the negative with the 1, can you see that I would go down 1 over 3? If I put the negative with the 3, that would mean I would go up 1, back 3. Still ends up with points on my line. So another point on my line happens to be 3, good save, 3, 2. Draw the line through those points. And we've drawn it using y equals mx plus b. Now, in this situation, you might get the feeling like, ooh, I might have made an algebraic mistake simplifying it, because dividing by 3 is a little bit difficult and changing everything to the fractions. Maybe I made a mistake. So what can you do? You can say to yourself, well, my other method of graphing was my table of values. According to this, when I plug in 0, I should get 3 for y. So you can check, is 0 plus 3y equal 9? Do I get y equals 3? Yes. That point is good. What about my other point? What happens when I plug in, oh, again, beautiful save. When I plug in a 3, that 3 looks awful. I can't handle it. Sorry. No. Oh, yes, much nicer. If I plug in 3 for x, so again, I'll go up here, I'll erase what I did before. I'll plug in 3 for x. Well, I subtract 3 on both sides. divide by 3, I get y equals 2. Yes, it matches my point. After doing those 2 points, I might even convince myself, in this situation, I like the table of values better than changing it to y equals mx plus b. Maybe. Maybe it was less work. Sometimes table of values is terrible. Everything you try, you get fractions. And you're like, I don't like this. Then you might want to have y equals mx plus b. And sometimes y equals mx plus b, you have fractions everywhere. Because if your b value is a fraction, then it's just not as nice. So sometimes we run into troubles with both of them. Should I make one up that runs into troubles with both of them? Yeah? Okay. We'll call this, is there an example 6? There's no example 6, so I can call it example 6. Sometimes there's example 6, then I would call this example 5.5. Okay, but we'll call this example 6. All right. Let's do 2x plus 3y equals 5. Nice and not nice. Okay? So, if I decide to change this to y equals mx plus b, I'm going to subtract 2x on both sides. I'm going to get 3y equals negative 2x plus 5. And then I'm going to divide everything by 3, which will change this to 2/3 x plus 5/3. So my y-intercept, if I am going to graph this, my y-intercept is a fraction, 0,5/3. And trying to graph this, well, now I'm supposed to go down 2 from that fraction and over 3. That's also going to be a fraction and not very much fun to label. Okay? So you say, ooh, y equals mx plus b doesn't work out very nice. So then you're like, well, maybe I'll try my table of values. You plug in 0. You're like, when I plug in 0, you get 5/3. Ugh, I have a fraction. So you try another number. You try negative 1. Plug in negative 1, so then I would have 2 times negative 1 plus 3y equals 5. Add 2 to both sides. 3y equals 7. Ugh, another fraction. And so sometimes the table of values also gives you fractions. But if you're lucky, you can find a value that works out nice. And I picked one that works out nice. Okay? What's a value that works out nice? Does someone find one that works out nice? What should I plug in for x? 3? Should we try 3? Negative 2? Someone says negative 2 should work out nice? Let's try it. If I try negative 2, erase everything I have so far. Oh, actually, I don't want to erase the y equals mx plus b. So that was negative 2/3 x plus 5/3. I'll save that over there for later. If I plug in negative 2, 2 times negative 2 plus 3y equals 5. Oh, this does work out nice because that's negative 4. Add 4 to both sides. Oh, beautiful. Y is equal to 3. And if you can find one nice point, so we found, and blue is a nice color, so I'm going to label it in blue, negative 2, 3. If you find one nice point, then you can use your one nice point with your slope and find other nice points. So my slope is negative 2/3. I could go from here down to boom, boom, over 3, bump, bump, bump. Can you see that 1, 1 is another nice point? Plug in 1 for x, 1 for y. Do the mental math. 2 plus 3. 5. Yes, it works. Beautiful. And you could do another down 2 over 3 and get another nice point. And this is our, wow, straight line through all of those points. Of course, I used my ruler. And we have our graph. So sometimes both the table of values and the slope-intercept form don't work well on their own. You kind of have to see, can I find a nice point? And there's a bunch of mental math that you sort of have to do in this situation. What I would do is I would say, what are values of x that I could put in here when I subtract them on the other side that I get a multiple of 3? Because I'm going to have to divide it by 3 afterwards. So 1 worked. Negative 2 worked. Those are some values that worked. And then your table of values ends up being able to use your slope to graph it nicely. Okay, next question. So changing things to y equals mx plus b is important because we're also going to look at how we can use our graphing calculators to draw these. So we'll start off just by looking at example, let's start off with an easy one. Let's look at example 3. Example 3 is already in y equals mx plus b form. I'd like you to take out your graphing calculator and learn how to graph with your graphing calculator. So with your graphing calculator, you can push the y equals button. I already have some things in there, so I'm going to clear them out. Most likely yours will be completely blank because you probably haven't graphed a lot before. Okay? The reason it has y1, y2, y3, y4, it lets you graph more than one thing. If we want to graph this equation in example 3, 2/3 x minus 3, what we can do is we can start by writing 2/3. There's two different ways you can write 2/3. You can write 2/3 just by going 2 divided by 3. But if you like to be fancy and you have a newer calculator, you can go alpha y equals, this menu comes up, and if you push enter on 1, it actually makes a fraction like that. Really handy. So I'm going to go 2 divided by 3 x minus 3. So it looks identical to my equation that we had before. What we want is we want our calculator to graph this same line that we have over here. So we hit graph. Oh, it looks nice. Oh, it looks really nice. Beautiful. There's that line. The same line that we graphed with our graphing calculator. So if you have your graphing calculators here, type that in, push graph, and sure. So you're able to graph anything if you can get the y by itself. Some nice things that the graphing calculator also does. We've checked how to change the window. Okay? There is a window button. So if you push the window button, if you've done zoom 6, you can see that your window goes from x from minus 10 to 10. On y, it goes from minus 10 to 10. Okay? This part here, the x scale, tells you where they're going to make those ticky marks. They're making one every 1. If I change that to 2, and now push graph, see how it's doing every other one now. Might be nice to keep it, go back to my window button, keep my scale back at 1. Right? But you could also expand your graph and say, maybe I want to go from negative 100 to 100. And now when I go graph, oh, I have a lot of ticky marks, right? And my graph changes its look because I'm stretched out the way that I look at it, right? Because now my x goes from negative 100 to 100. So often if you've changed your window, it's nice to push your zoom button and go back to number 6 to standard window, which goes from negative 10 to 10. Some other nice things that your calculator has. Once you put the equation into your calculator, above your graph button says table. So if you go second graph to go to a table, it figures out your table of values for you. When you plug in 0, you get minus 3. When you plug in 1, you get a fraction, negative 7 over 3. Your calculator might have the decimal. That's okay. Okay? When you plug in 3, you get another nice number. Now, I once had a student that decided during class they would go down and spend 10 minutes trying to figure out how far they could go. Just pushing down and down and down. And they got to like thousands and thousands. Then we did another question and we had to get back to 1. And so I let them go up for a long time, about 5 minutes. And then I said, you know, above the window button is a table set button. Right now I'm starting at 8, right? So second table set, I could just start it at 0 again and push enter. And then when I go back to my table, it starts at 0 again. That is even faster. So the table of values is built in. Really cool. Okay? If I go back to my graph, there are some calculations that your calculator has built into it, which are also really cool. All of the calculations are above the trace button. The trace button itself just puts a cursor on there and you can move it along and it figures out points as it moves, which is kind of neat. But above the trace button, second trace, is a calculate. And the calculate button lets you do a bunch of different things. So let's look at each of them. I want to calculate a value. Well, we're not going to look at each of them because some of them are calculus and stuff. And some of them don't apply. But number 1, a value. It says, what value would you like to find? I want to know when x is equal to 0. Because if I plug in x equals 0, which point do I find? The y-intercept. Boom. Oh, you want your y-intercept? It's negative 3. Thank you. Okay. I could type in 2, and it will tell me, oh, at 2 it's negative 5/3. On your calculator, it might have the decimal. That's okay. It might say negative 1.67. Second trace. What else does it do? It finds 0. Well, let's see. What does 0 mean? A 0 is another word for an x-intercept. And the way that the calculator finds the x-intercept is it says, look on your graph where the x-intercept is, and make your cursor on the left side. Is my cursor to the left of the x-intercept? Yes. So then you push enter, and it draws a line. Some of the older calculators just draw an arrow. And then it says, go to the right of it. So I move my cursor until I am to the right of it, or until my, no, it didn't freeze. You can also, if you can tell, oh, 8 is definitely to the right of it, you can just type in the number 8, and it moves to the right of it where 8 is. It draws 2 lines. Is my x-intercept between those 2 lines? Yes. Then it says guess. I think it's going to be there. I don't know why it says guess. But you have to push enter one more time after you theoretically have guessed. And it will find your x-intercept for you. When x is 4.5, y is 0. So that is very nice. Other things it can do is it can find minimums, maximums. Well, this line keeps going up forever. It has no maximum. It keeps going down forever. It has no minimum. So that doesn't really help us in this situation. you can find where two lines intersect, but we only have one line. But if I wanted to type in another line, let's say I write negative 3x plus 5, and I graph that second line. Do they intersect? Yes. Where do they intersect? I can go second, calculate, number 5, intersect, push enter on your first curve, push enter on your second curve, guess. And they happen to intersect when x is 2.18 and y is negative 1.545. Whew. Right? And that's going to be our last unit, finding where two lines intersect. So the graphing calculator is very helpful, and you can play around. You can like graph. You can graph different things. Oh, what does x squared look like? And hit graph, and see what different shapes of different graphs look like, and play around with that. But for now, we're just graphing lines. And that's at the end of the page here, different things that you can do with graphing lines. Okay? So we sort of skipped this example 1 and 2, graphing using two special points. You can always also graph by finding the special points of an x-intercept and y-intercept. So we did this before as well in our relations unit, right? The y-intercept is the point where it crosses the y-axis, and the x-intercept is a point where it crosses the x-axis. So I'm going to add 3, graph 3x plus 4y equals negative 12. So yes, you could use your first method, make a table of values. You could use your second method and rearrange this d equal y equals mx plus b. You could also use your intercepts to graph this. So if I wanted to first find my y-intercept, what do I have to plug in to find a y-intercept? What always happens with a y-intercept is the x-coordinate is 0. So if I plug in x equals 0, well, then I would have 3 times 0 plus 4 times y equals 12, negative 12. Divide both sides by 4, and I find out that my y-intercept is negative 3. Next, I find my x-intercept. What always happens with an x-intercept? The y value is equal to 0. And so I plug in 0 for y. I'd get 3x equals negative 12, divide both sides by negative 3, and I get a y-intercept. An x-intercept of negative 4. Once you have both your x-intercept and y-intercept, you could draw your line. The nice thing about using your x-intercept and y-intercept, you could also then look at your line's equation and say right away, I know that my equation in y equals mx plus b form is, well, what have I done to go from one point to the other? I've gone down 3 and over 4. So it's going to be negative 3/4 x minus 3. So I could use my graph to change it to y equals mx plus b form as well. Okay.